Welcome everyone to our webinar, Your Guide to nrgpy, an open source Python package for easier data interactions. Thank you very much for taking the time out of your morning to join us. I'm here with Dave Carlson, who is NRG's Manager for Special Software Initiatives. And Dave has been in the wind industry for 17 years. During this webinar, Dave will be discussing nrgpy, which is NRG Systems' open source Python library for programmatically working with the data collected by NRG Symphonie Data Loggers. nrgpy can be used to jumpstart data analysis and visualization, automation, and more. Dave will be covering a lot of ground in this presentation, including how to set up nrgpy on your computer, using the NRG Cloud API to download data, reading text data with nrgpy, plotting text data in Jupyter, and he will provide links to example notebooks and code as well as some live demos. After the presentation, we will do a Q&A session. So please submit any questions that you come up with during the presentation using the questions tab in the GoToWebinar interface on your screen. In the interest of time, we won't be addressing questions on the fly, but we'll try to cover as many of them as we can after the presentation. So with that housekeeping out of the way, I will turn it over to Dave.
And we'll turn the camera this way. Awesome. Hi, everybody. Thanks again. Thanks, Brittany, for setting this up, and thanks, everybody, for joining. This is something that has a special place in my heart. I love open source and I love working with Python. So let's get started. Click. So today on the agenda, we're going to talk about what nrgpy is and how it can be used. We're going to talk about contributing to the open source package and how to do that, how to be a part of the nrgpy club. We'll go into setting up a development environment. So from not really having anything but Python installed on your computer, how to set up a space where you can use nrgpy and get started. We'll go through a basic example, just creating a reader from some NRG Cloud data, and then we'll do a plotting example, recap, and field questions. This shouldn't take the full hour to get through the presentation, so there should be plenty of time at the end if anybody has any discussion topics. So what is nrgpy? nrgpy is an open source Python library that we've developed here at NRG. We initially were developing it internally to do data analysis on Symphony Pro, and we saw the value in it, so we decided to make it available to the community. It includes a series of tools for handling NRG device data formats. So that includes the Symphonie Data series from Symphony Classics that were the original data logger model from the early 2000s, Symphony Plus, Symphony Plus 3, as well as Symphony Pro. It also has support for reading in Logger. So the new Solar data logger that we have, you can read those DAT files that can be created by that logger, and it includes support for SPIDAR CSV files. So that's kind of the reader function of everything, as well as conversions. So on those Symphony Data RWD and RLD formats, those are binary files, and the Python library includes some tools for converting those programmatically. Excuse me. Another piece that it includes is API, like some built-in API classes for accessing the NRG Cloud platform. If you're not familiar with NRG Cloud, you can sign up for free to look at some demo data, and we can go over that a little bit later in this presentation. The nrgpy library, as a Python library, as an open source Python library, also relies on some other open source libraries, including pandas, which if you've ever done data analysis in Python, you're probably familiar with. PSUtils, which is just for doing some system checks as it's running, and the requests package, which is what the API classes are based on. It's used mainly for data analysis and also data handling automation. So you can use nrgpy to convert the RLD and RWD binary data files into text files. You can use the package to combine those text files. So instead of having a month's worth of daily text files, you can combine them all into one, or a year's worth of files, or whatever you like. And then read that text data into these objects that are pretty handy and pretty easy to navigate if you're using like the Jupyter environment that we'll demonstrate in a little bit here. It's also a pretty good package if you're trying to prepare data for other analysis or for database integration. So if you're going to be feeding all of your Symphonie Pro data or logger data into a database for longer term storage and access, it's a pretty good starting point for that, as well as running automation. So if you're downloading files from an email and you want to automate handling those, it's a pretty good starting place for that too. I talked about contributing. So the package is hosted on GitHub. It's also available via PyPy, which I didn't post here, but if you've ever installed a Python package with pip, you can install nrgpy with pip and upgrade it through the pip package manager. It's available. You can go to github.com/nrgpy/nrgpy and see the library. That's where you can use the issues section if you have any bugs that you want to report or any problems accessing features, as well as if you have any new features in mind or improvements on how it operates. That's a great place to be a part of this open source product and submit issues, submit ideas. And then if you're familiar with or happy to use Git and pull down the actual source code, you can use pull requests to submit new features or bug fixes. There's a bullet here on the page that talks about a good example of using pull request processing. It's called first contributions. It's supposed to be a link, but of course, I don't think you can click it where you're at now. But if you search for the first contributions GitHub repository, it gives you a really good step-by-step on how to use pull requests to be a part of open source projects online. So getting started, we're jumping right through, and we'll use this link at the very top to get started. So I'm going to actually switch and go over to this link. If I can figure out how to use this here, it's this one. So you should be seeing my, let me just check with Brittany. Yeah, thumbs up, great. So this is the intro nrgpy repository, and this basically just has the demo files that we'll be working with today. For example, there's a nrgpy notebook here. You could download this notebook and use it on your own computer. There's also there's an instructions file here that goes through what we're about to do to set up a virtual environment and install the packages that we need and get your cloud credentials and then use the notebook. So this is here, this will stay up. Feel free to use this as a reference later if you want to run through this again or need to set this up on a new computer. And again, you can use the issues area of this if you have any questions on the intro. While I'm here and I'm on this screen, I can just show you the nrgpy repository. So here we are at github.com/nrgpy/nrgpy, where the open source package lives. So this also includes links to documentation. So all of the code is pretty well commented, and we've used those comments to spin up this documentation page. So if you're looking for how to use something, you can either look at the code itself or use this. This documentation too, if you're using something like Visual Studio Code to do to use nrgpy, all the IntelliSense stuff that works there will work and actually like show little pop-ups on how to use all the different classes that are written into this this package. So yeah, nrgpy. I'm going to switch back over to the. Forgive me for my slow switching here. This isn't something I've ever done before. So is it this one? Thumbs up from Brittany. Good. So in order to use nrgpy, you'll need Python version 3.6 or higher. Today I'll be using Python 3.10 or 3.10, which is the current release. We're doing the demo on Windows. If you have Linux or Mac, you won't need admin access, but the way we're going to go through it, it's easier if you have admin access to get it set up. But we're going to set up a virtual environment and install nrgpy and Jupyter, and then create a new Jupyter notebook and go through some demonstrations. Gonna switch Windows again. So forgive me, I'm going to look away here as I go into this, so you get to see a lot of this side of my face for the next few minutes. So we can check our Python version, and you can see that I'm using version 3.10.4. Now what I'm going to do is create a virtual environment using the venv package. So what this does is it essentially creates a compartmentalized area on the computer where I can install Python packages of different versions and then use them for whatever I'm doing for that specific purpose, and then I can deactivate it and go use a different virtual environment on my computer. So I can do development in different areas and they don't really pollute each other. The other thing this is good for is if you're going to do automation with nrgpy or really any Python package, using virtual environments are a good way to just create a very controlled environment for the processes that you're running, so that if there's something else happening on your computer that requires different packages, they don't affect each other. So I'm creating the virtual environment, and I'm going to be not very creative here and just call it venv again. And that's gonna, I clicked enter, it's gonna basically set up this whole Python development environment in the background. So you get to watch this blinking cursor here for a couple more minutes. While that's going on, oh, that didn't take as long as I thought. Okay, so now if I list it, you can see there's this new folder called venv. I can run a script from within venv called activate. And now you'll see on the side here that venv shows up before my command line. So that means my virtual environment is activated, and now I can start to install some packages. So I'm going to use pip to install nrgpy, of course, and I've got a list of the other ones that I wanted to use here. We're also going to use matplotlib. I don't even know how to say that, but it's a very popular, very straightforward but powerful plotting tool. We're also going to install windrows. You can guess what that does. And then Jupyter Lab. I like Jupyter Lab. It's a newer version of Jupyter that has some additional features. So we'll install those. All of those are getting installed only in my local virtual environment. And it'll go through and collect all the packages that it needs to, collect all of the requirements that they have. You can see a lot of different stuff getting installed here, and most of that is for the Jupyter notebook environment. So this will take another minute. I think when we ran through a practice run, it hung out on this Tornado installation for a while too. Tornado must be a good one. Thanks for sitting in this awkward silence with me. I really appreciate it. I guess while this is loading, Brittany, are there any other questions that came in?
Yeah, we can start going through some of these. So one that has come in so far is someone asked, can nrgpy be used to convert RLD and RWD files?
Right, yeah. So there's some packages, and let me just switch over to this other window. There are some examples here. If you go to nrgpy's GitHub page, it does provide tools for converting the RLD and RWD files to text format. And if we scroll down a little more, we don't even need to get into the documentation because there are some examples here. Like here's an example for converting a folder of RLD files to text. It shows importing the nrgpy package, setting a date filter to say, hey, I just want to convert the files in this folder from December 2018. And then we can run through and do what we're calling a local RLD conversion. So if you're going to do conversions of either the RLD or the RWD files, it will require that you have, for RLD, you'll need Symphonie Pro Desktop installed. And for RWD files, which are a little bit further down, I think, you'll need Symphonie Data Retriever installed. If you go to run this and you don't have those installed, you should get an error and a link to where to find that download. So I noticed that the installation was able to complete here. So we, sorry, here, got lost here. So we were able to install everything. So now what I'm going to do is run the Jupyter lab. So when I run this, Jupyter is running natively. There's lots of different ways to use Jupyter, and like programs such as VS Code or Visual Studio Code, you can run these notebooks directly in there. So if that's what you're familiar with and that's how you've done these sorts of things in the past, you could take the example notebook from the intro NRGpy repository and you could just run it in VS Code. Totally fine. But I'm going to run it directly, and this is going to spin up a web server here, and then it's going to kick over, and it automatically opened a new tab on my browser. So I'll switch back over to the browser, and we'll see this thing load up. Great. So it shows me the NRGpy example notebook because I did have it open at one point. What we're going to do is just kind of run through this. So I can run each of the cells in this notebook. Maybe it makes sense to just kind of talk about what we're looking at here. So we've got a Jupyter notebook is set up with cells. There's different cell types. You see this top cell is a markdown cell. That's just text. If I click in here, you can see it's just got some symbols and stuff. But it's a markdown language that you can use to make things look kind of nice if you're adding text. So I've got that. The next cell here has some brackets on either side. This is a code cell. I can run it with Shift Enter, and it'll kick me down to the next cell. You should see this little asterisk turn into a 1. So I've imported NRGpy, I've imported pandas, and now I can move on to this next section where it's telling me to retrieve my API credentials. So there's a link here in the example notebook. I'm going to just click over to the cloud, and you can also get your credentials by clicking the little person icon in the corner and going to API setup. So this particular account I set up just for this demo. So if you see my client ID and client secret, that's okay here. In general, you'll want to keep your client secret to yourself because that is going to allow you access to all of your sites. So these credentials are something that you want to protect. In the notebook, we talk about putting them in a separate file so that then you can just import them instead of putting them in line. But I'm just going to put them in line for this demonstration because probably after this demonstration, I'll delete the account anyway. So I copied my client ID and I'll go back over and I'll copy my client secret. Put that in here. Oops, if I can click. So then I ran this cell, and that sets up these client ID and client secret variables, which I'm going to use to see what sites I have access to. So I'll run this. When I run it for the first time, it's going to tell me, it's going to go out, it's going to get a token, authenticate, and then if everything looks good, I'll get the OK. So I got the OK. These session tokens last for 24 hours, so you won't need to get them very often, but you will need to access them. The nrgpy cloud methods take care of handling the tokens, so you don't have to worry about manually doing that. So this sites df, it's a data frame, and it shows me I have access to these 3 sites right now. That's, you know, if I had 100, they'd all show here too. DataFrames are a nice feature. We've used them here in nrgpy. We've used them in other Python libraries that we've developed internally. They're really well supported. If you want to do something with a data frame, if you Google search it, somebody's already done it. So it's pretty easy to move forward if you're using Pandas data frames. This next section will do an export. So you can see here I'm using the cloud export package. I'm going to create this little exporter. I'm going to use the same client ID and client secret. I'll have to pass the client ID and client secret for any cloud API calls that I do. I'm going to pull from site number 110. So I'm putting in site 110 here, and I'm going to just pull this about month and a half of data. So I'll create the exporter and then I'll run it. This section here will take, because we're getting a month and a half of data, yeah, you can see it took about 10 seconds or so. So great, now I've got this exporter. That's all pretty simple. If I click open this file browser on the left and scroll down, I can see that I've got this crow's nest measurement data. It's a 2.4 megabyte text file. So we're going to read that file in. I guess while I'm doing this, I'll make a new cell, and you can see if I type in exporter dot and hit tab, these are all of the attributes of that exporter. So you can see things like the export file path. So the export file path, if I run this cell, is where I save the output. So I'll use that down here, and comment this one and uncomment this one. So you can see I'll create this reader using the SimProTextRead class, and the file name I'm passing it programmatically using the exporter above. So I could, in the line below, I have it spelled out where I'm actually, saying the name of the file. But here above, I can just use this export file path and create a reader. And then just as an example, you can see some of the attributes of the reader. This is for site 110, and it's located at this latitude and this longitude. And again, if I open the reader and I type in reader dot and hit tab, I can see the attributes here. There's a lot of attributes that are baked in here. including channel info data frame, which includes a data frame of all of the sensor attributes. There's some metadata around the data and elevation, file name, and all of the instrumentation information, the IPAC serial number and type, the logger serial number and type, and there's some functions in here. So I won't go into that, but just to say you can explore the reader with the tab key and you can see all the different things that are in here. Like the serial number, for example, which got a little mangled for some reason. Down here under quality, there's some built-in functions that check quality of the data. So I'm going to run this nrgpy check intervals function on the data frame, which is a part of the reader. And I can see that it was expecting 4,463 rows, and it got them all. So there's no missing timestamps. This is a dictionary that it returned that gives me some information on the timestamps. If I change this verbose to true, it does a nice kind of printout of it to show me the starting interval and that sort of information. I mentioned the channel info data frame. If I run this cell, we can see what's included in that data frame. There's lots of information, the serial number, channel, effective date. Essentially, if you've ever worked with Symphonie Plus or Symphonie Pro data, there's a header on the text file, and this parses that header on the text file to give you this information here. So hopefully that makes sense. Certainly if I breezed over something too quickly, feel free to put a question in that we can talk about at the end of the presentation. Again, trying to find out where I am here. This one. So we did a quick demo on, we did a basic example on how to access NRGpy, the NRG Cloud API, where to get the credentials, how to see the sites, how to export data. And we also created a reader object and showed some of the attributes of that. We'll continue on with the same demo and we'll just look at some plots. And then that should close us out and we can address any questions that anybody has. So let me switch back to that Jupyter notebook. Scroll down. So these are some plots that I'll demonstrate some plots using these two libraries, the matplotlib and windrows libraries. The windrows library is actually based on matplotlib. Both of these are open source libraries. They're free. You can download them. You could contribute to them if you have any ideas on how to make them better. But I'll just move down here. So I'm going to import the NumPy package. I'm going to import matplotlib, CM, which is like a color. I forget what it stands for, but to set some colors. The matplotlib.pyplot is a pretty standard way of plotting time series data. And then we'll import the plot windrows function from this. So if I did everything right when I was setting up my virtual environment, all of these should come in. So we've got all of our libraries loaded. I'm going to use the channel info data frame to locate my anemometers, and I'll show you that. So I'll create a list. I'm not sure if I'm creating a list or a data frame. Let's see here. Yeah, so I created a data frame of the wind, or a data series, I should say, of the wind speed channels. So channels 1, 2, and 3 are type anemometer. And just to double check here, if we scroll up, we'll see that the type in this channel info, these 3 are anemometers, 1, 2, 3. So I'm going to create a subplot plot object, and for each of the channel in my wind speed channels, I'm going to create a plot. So I'll run it and then we can kind of talk about what happened here. So if I run it, I can see there's some time series data from our SimPro crow's nest that's been plotted. I'm adding some elements to it, such as a legend and a title and the y-axis units. But this is all this is like a simple example of plotting using Matplotlib's sort of default formatting. I'm not sure, now that I'm looking at this, I'm not sure if I've ever finished this strip plot, so we'll just run it and we'll see what happens. Oh, I did. Okay. I did make it work, but it doesn't, the formatting is a little funny, so it needs a little bit of extra work. I'll be sure to submit some changes to the intro NRGpy GitHub repo when I get that fixed. But you can see just another way of plotting sensors sort of in a row. And then we can look at the veins that we have. So in this next one, I'm using the channel info data frame, and I'm looking for channel info type equals anemometer or channel info type equals vein. So you can see I'm getting 3 anemometers and 3 veins. Here I'm doing some list comprehension to grab an anemometer call. So I'm making sure it's channel 1 and it's the average. The vein call is channel 13 and it's the average. Then I'm going to create a data frame. So the Windrose package likes to see a data frame with a speed column and a direction column. So I'm going to create that data frame and then use the plot Windrose function, pass it that data frame, and make it a bar type. I'm setting up an array of bins here, and I'm setting the color map to plasma and a title and showing it. So I'm just going to run it, and if everything's correct, we should in a minute here see a Windrose. Look at those pretty colors. So that's the Windrose. And I guess one thing I haven't talked about yet is the reader.data data frame. So I just ran that, and this is the actual data itself. So this includes all of the data that would have been in the text files in the data block down below. And if I hold down Shift and scroll, you can see all of the different statistics for each channel and all different channels as I keep scrolling along. So that's pretty much what I wanted to cover with the presentation today. If I go back to this guy, we can close out. So we've entered in the questions and discussion portion. There's a couple of links here that were shared previously. The first one is for these example tools. The second one is for the nrgpy package. And the third one is if you want to email me if you have any questions. So with that, did any questions come in, Brittany?
It did. Thanks, Dave. That was super informative and great to see NRGpy in action. We do have a couple questions here, so I'll just dive right into those. Somebody asked, how does cybersecurity and SSL come into play when you're working in NRGpy?
That's a good question. So when we're working with the NRG Cloud APIs, all of the connections that are made using those APIs are done over HTTPS, which is very, very common standard for encrypting internet traffic. So that's very secure. The other functions in NRGpy aren't using any sort of internet traffic, so they're not really subject to that.
Great. And another, does NRGpy have any built-in plotting tools?
Right now, there are no built-in tools. The demonstration that we just gave for using matplotlib or the Windrose tool are, some ways to plot the data. There's also other Python plotting libraries that are pretty great. I know I really like Bokeh. I'm just getting started with that. There's a few people here at NRG who are really good with Bokeh. And that one's cool because it's really portable. You can share the plots in a variety of different ways. Another common one is Seaborn. A lot of people like to use Seaborn. It does a good job of setting pretty colors, which is always nice.
Another question just came in. Is there a plan to integrate this with the data standard from IEA Task 43?
Oh, that's a good question. So for anyone who's unfamiliar, IEA Task 43 is a standard being developed and implemented. Really, it's starting to get a lot of traction that standardizes on the metadata that should accompany a site and how to present that metadata. It's generally done in a JSON format. So we definitely want to do more as a manufacturer to support that standard, and NRGPy seems like a pretty good place to put some of that, but we're still trying to figure out the best way forward. It might be a separate package, or we might be able to put it within NRGPy, but thanks for that question.
Another one, it seems like NRGPy is still under development, and do you want to automate reporting as well in the end?
Yeah, so the NRGPy package is under active development. We're at version 1.7 and continuing to add features to it. I think where we're at in this phase is, this is our first real public outreach event on NRGPy. So looking to drive engagement. The idea of automating reporting or doing some sort of reporting functionality sounds pretty cool. And I'd ask anybody else on the call that has ideas for feature improvements or ideas on how to expand this to either submit issues via the contributing guidelines that we have on the GitHub page, or to even get involved and become a more active contributor with code pull requests.
Great. So that just about wraps up this presentation. We'd like to thank you everyone who attended, and we hope you found it informative. We will make a recording of the webinar available. It should be emailed to you at some point tomorrow. And if you have any questions that come up after we sign off, feel free to shoot us an email. You can email Dave directly at the address you see on the screen, drc@nrgsystems.com. You can also send questions to info@nrgsystems.com, and we will get back to you. So again, thank you for joining us, and we hope you have a great day.